Hello and welcome to another one of these ADD videos. Today we're going to be looking at cell potentials, free energy, and the Nernst equation. If you guys remember, delta G, Gibbs free energy, is a measure of spontaneity of a reaction. And if it was less than 0, spontaneous, greater than 0, not spontaneous, equal to 0 at equilibrium. Well, delta G is also a measure of maximum useful work that can be obtained from a chemical reaction. Okay. And if we're talking about work of an electrolytic cell, or electrical system, not electrolytic cell, we can use this equation here that takes the moles of electrons times Faraday's constant, which is 96,500 coulombs per mole, times the standard cell potential. And if we set the two works equal to each other, we come up with this wonderful equation here. Okay, so you might be given different pieces of the puzzle. Once you know the equation, usually it's not too much. Figure out the worst part of this might be figuring out how many electrons you have, and usually you can tell by the charge and the coefficients of your chemical equation. If you remember your Gibbs free energy thermodynamic stuff, that delta G is also equal to negative RT ln of K. Well, if we set the two delta G's equal to each other, because one of them equals that, and the other one equals that, then we can come up with another equation for the cell potential. And that's RT over NF times ln of K. R is our good old gas constant, joules per mole Kelvin, 8.314. Temperature is always in Kelvin with this equation, number of moles of electrons, and Faraday's constant. Okay. Now, if you remember, our concentrations might not be 1 molar, so we can use the equivalent of this equation in terms of standard potential. If you do a little algebra, and those equations that we have over here, like that one right there, then you can get the E of the cell to be the standard reduction potential, which was the cathode minus the anode, minus this thing, where Q is going to be the concentration of the oxidized over the reduced. Now, be careful. Some of these might be heterogeneous reactions, and these heterogeneous reactions, we don't care about solids and liquids. We only care about the aqueuses. So you're just basically going to be given different pieces of the puzzle, and you're going to be asked to calculate these values. So use the appropriate equation and go from there. All right. So first equation that you should know, I'll go back through and put a little asterisk, is this one. These concepts are all important. This one you should already know. And then when you set them equal to each other, you get this equation here. That's important. And then the Nernst equation. Okay, Nernst equation actually can be used in calculating potentials across membranes and stuff like that for neuroscientists out there in training. This won't be the last time you see this equation. So practice these, and thank you, and have a nice day.